Okay, so page 427, numbers 21 to 23. And I purposely put these ones before these other set because I think these ones are easier. So I thought I'd start you off and give you some hope. Right? You saying, oh, these are easy. So 21, an air column opened at both ends resonates with the fundamental frequency of 256 hertz. So F1 is 256 hertz and it's opened at both ends. Determine the frequencies of its first and second overtone or second and third harmonic. So opened at both ends, and it's just 2 times F1, 2 times 256, which is 512, and then 3 times F1, or 3 times 256, which is 768 hertz. Okay, that's it for number 21. Number 22. A bugle is essentially a 2.65 meter pipe that is opened at both ends. So L is 2.65 meters, opened at both ends. Determine the lowest frequency. So if it's opened at both ends, F1 is equal to V over 2L. Now it doesn't tell us the temperature, so we assume it's 20 degrees. And if it's 20 degrees, then what does that mean the speed is? 20, 11.8, 342.8 meters per second. So 342.8 meters per second divided by 2 times 2.65 meters. And for some reason I don't have that answer. 2 times 342.8, no, divided by 2.65. 64.67, 9. So F1 is equal to 64.679 hertz. Okay. Number 2 says determine the next two higher frequencies. So again, F2 will equal 2 times F1 and F3 will equal 3 times F1. So 2 times that's going to be 129.358 hertz. Whoops, didn't need a bracket there. And then 3 times that, 1820. I can't do that in my head. Well, I can, but I'm not going to. 194.038 hertz. Okay? Number 23 says a trombone is playing F, which is the frequency is 87.3 hertz, and that's an F apparently note on the trombone as its first harmonic, so it's F1. A trombone functions as an air column that's opened at both ends. Determine the second harmonic, so F2 is equal to 2 times F1, so 174.6 hertz. That's A. B. If the speed of sound is 344, what is the length of the tubing being used? So for B, F1 is equal to V over 2L, so L is equal to V over 2F1. So what do they tell us? 344? Yeah, 344 meters per second over 2 times the 87.3, right? Because it goes back to the fundamental in this equation, 87.3 hertz. And you should get a length of 1.97 meters. Okay? All right, so then flip back to page 421. Number 16 says, a narrow plastic pipe is almost completely submerged in a graduated cylinder full of water, so it's a closed tube. And a tuning fork is held over the open end. The pipe is slowly raised from the water An increase in loudness is heard when the pipe is at 17 centimeters. So L is 17 centimeters. And in a closed tube, the first loudness that you hear is a quarter of a wavelength. So L is equal to 1/4 lambda, or lambda is equal to 4L. Determine the wavelength. So lambda is equal to 4 times 17 centimeters. Lambda is equal to 68 centimeters. Okay? Now it does tell you other things in the question, but you don't even need it to find lambda. So then it says the pipe is continued to be raised. How far from the top of the pipe will the water be when the next increase in loudness is heard? Oh, actually, I should have continued to read it, because it says the first one's 17. The next one it says is 51. And that will be L is equal to 3/4 lambda. And then the final one will be 5/4, the one that they're asking for. Right? L will be equal to 5/4 lambda. And so we have lambda now, so L will be equal to 5/4 times 68. So L will be equal to, divide by 4, 17 times 5, 85 centimeters. Okay? I guess I should finish the box. All right, next question, number 17. Says, the first resonating length of an air column for a fixed frequency is 32 centimeters. Okay? So it wants to know, determine the second and third resonating lengths if the column is closed. So if the column is closed, the first one is a quarter wavelength. The next one is 3/4. And the final one is 5/4. Okay, so you remember when we were doing these on the other video, I said to you, if you remember the diagrams, like just the first diagram, you just add a half wavelength each time. So for this one, L is equal to 1/4 lambda, which means lambda is equal to 4 times L. So lambda is equal to 4 times 32 centimeters. So lambda is equal to 124 centimeters. And that becomes important when we go to the next one, because this one, L is equal to 5/4 lambda. Oh, I don't count well. Let's try 3/4 lambda. L is equal to 3/4 then of 124. Okay? So L is equal to 96. That's the second length. The third length, L is equal to 5/4 lambda. So L is equal to 5/4 times 124. So L is equal to 32, 156, I believe. Did I do that right? 5/4. I better check that math. It doesn't seem right. Times 5 divided by 4. Now I really got something wrong because it gave me 155. 124 times 5 divided by 4. Is it 155? Really? Oh, I know what the problem is. The length. This is 128. That's why I'm getting the wrong answers. 128. And this one I cheated, so I think it's right. But that's why I can't get the right answer here, because this should be 160. I think. But I couldn't get it math-wise. 5 times 128 divided by 4 is 160. The reason I knew it needed to be 160 is I was adding a half wavelength each time in my head. And that's how I got this one right, because half wavelength is 64, and 64 and 32 is 96. But then this one I